Okay, problem 3-116. We are taking a look at this function g of x and trying to figure out a bunch of things with it. So first of all, we want to take a look at the domain and range of that. If I would draw a quick sketch looking at the function, we have 2 is our a value, that's our vertical stretch. We have x plus 3 squared, but we do not have anything after it, which would normally be our plus k. So our plus k, that means we have 0 as a k value. The x plus 3 is our h value, and if I set that equal to 0, that means I get x equals a negative 3. That tells me that this parabola has been shifted to the left 3. There was no k value, so it has not been moved up or down, and it's vertically stretched by a factor of 2. So a real quick sketch on this one means it'd be shifted to the left 3, my vertex is right there, and stretched. So now to talk about the domain of this function is going to be all real numbers, because the parabola is going to continue to the left forever, it's going to continue to the right forever. All x values will work with this function, so the domain is negative infinity is less than x, which is less than infinity. For the range starts, the possible y values, at 0 and only goes up. There are never any down here. Does not work. So the range are all values greater than or equal to 0, because 0 actually does work. So y is greater than or equal to 0. The next part of this problem is calculating these. So basically we're evaluating the functions at those points. So looking first at negative 5, I want to take a look at this function here, g of x. And when x here is negative 5, I'm going to substitute in negative 5 for x. So it's going to be g of negative 5 will equal 2 times negative 5 plus 3 squared. Working inside the parentheses, negative 5 plus 3 is going to be negative 2. Negative 2 squared is going to be a positive 4. And 2 times a positive 4 is 8. So that means that when the x value of this function is negative 5, the y value is 8. So I evaluated the function at negative 5. We're now going to do the same thing with g of a plus 1. Same setup, it's just going to look a little different. So let me clear this screen. So g of a plus 1 is going to equal 2 times, now instead of writing x, I'm going to write a plus 1. Plus 3, and that is squared. Simplifying inside the parentheses is just 2 times a plus 4 squared. My next step now is to actually multiply that out. So I can do a little side part here and do an a plus 4 and a plus 4. So I get an a squared, 4a, and 16. Combining the like terms, I'm going to end up getting then for this problem 2 times a squared plus 8a plus 16. My last step now is distributing the 2. So my final answer then for g of a plus 1 is 2a squared plus 16a plus 32. So g of a plus 1 equals that. Last part of this problem now is taking a look at finding our x values when the function equals these values. So what I'm going to do is g of x and g of x, when it equals this, I'm going to set it equal to 32, and for the next part I'm going to set it equal to 0. So two separate problems here. So again, let me clear the screen. So I have 32 equals my function 2x plus 3 squared. Now I am solving for this x value. So step 1 in solving, divide both sides by 2. 16 equals x plus 3 squared. This makes a giant 1. My next step here is to take the square root of both sides. That gives me the positive and negative possibilities here. So I have both plus or minus 4 equals x plus 3. My next step then is to subtract 3 from both sides. So x will equal a positive 4 minus 3 is going to be 1. And a negative 4 minus 3 is going to be negative 7. So when g of x equals 32, I get those two solutions. The very last part of this problem is when g of x equals 0. I'm going to set up the exact same way, but instead of using 32 here, I use 0. So 0 equals 2x plus 3 squared. Same steps as before. I divide everything by 2. There's my giant 1. 0 divided by 2 is still 0. Equals x plus 3 squared. I then take the square root of both sides, and the square root of 0 is still 0, equals x plus 3. And then I subtract 3 from both sides, so I only get one solution here. It is negative 3. You could see that answer actually when we graphed it in the very beginning as well. When the y value was 0, the x value was negative 3. And there's the problem.